Hey guys, how you doing? Me and over here Ainsley, she's there somewhere. We're just want to do a quick little video to walk you through Digital Labcoat. For those who have done it in AO1, it'll be mostly the same, but it may look a little different than it did at that point in time. So that's why we want to do another video, just kind of walk you through it and make sure everybody's clear on how everything works. Now, as you know, Digital Labcoat has multiple phases. You've already done the survey phase. So this video is only going to focus on phase 2, the analyze phase, and we will create videos as we go along for phase 3 and phase 4. So first thing is, when you log in, we're in a demo site now. Ainsley will give you the right URL in the announcement. But when you log in, you will see a screen that looks like this. I want to point out a couple of things. The home button, this is actually the home screen. So on various screens you will see the home button, and anytime you press it you will come back to the screen. So it's a way of, if you're ever in the middle of something or you screw something up and you want to come back here, you can do so at any time, and obviously you can log out at any time. But what we're going to do now is jump into phase 2. So we do that just clicking the active. And again, alright, so what phase 2 is all about is doing analyses on the data set. Now the data set I'm going to use for this demo is actually the one we used from intro AO1. So you will have different variables, ones that are consistent with the survey that you did. So yours will, whatever the survey was about in your term, we may use this in subsequent terms, so I'll try to be generic here. You will have questions related to that. But the first decision you have to make is whether you want to do a correlation or a t-test on the data. So again, a correlation you would use to see if two variables, if there's any kind of relation between those two variables. A t-test you would use if you want to see if some variable is different across two levels of some other variable. I'm going to do both, and so I think by the time I'm done doing both you'll have a good sense of how they differ. But I do also want to highlight at the very bottom of this the submit an analysis. The way this step works is you can do as many analyses as you like, but whenever you think you're finished, and I'll come back to why you might think you're finished, but whenever you think you're finished you can then submit one analysis, or in fact multiple analyses if you want. Now, why would you think you're finished, and how do you decide which analyses to submit? Basically what I want you to be doing here is trying to find something interesting. Either something you think that has real good psychological relevance, maybe because of what you've been reading, or maybe simply because it's unexpected, it's surprising. Ultimately where we're going to go with this is we're going to get in this step hopefully some interesting findings that are submitted. We're then in the next step going to try to replicate some of these findings to see which ones are consistently found and which are not. And that will leave us with a list of our top 10 most interesting replicable phenomenon. And in the fourth step, I'm going to ask you guys to either provide theoretical accounts about those interesting results, or to vote on the theoretical accounts that are there. So all of that to say, it's kind of cool if yours is one of those ones that makes it to the end, and that's what I want you thinking here. I want that you're going to do some analyses to try to find something that is sufficiently interesting that it might make it right to the top 10 most interesting findings. So this is your chance to just play with data. So let's give you an example. I'm going to start by showing you a correlation. So I'm going to click on the Pearson correlation. When you do, you get this screen, and basically what this is asking you is, well, which two variables do you want to look at? Which two do you want to assess whether there's some sort of relation? And I kind of want you going into this with a bit of a scientific mindset. So when you click on one of these, it will show you all the variables that are available for you to play with. And so basically you could look at these variables, and as you do, kind of think, hey, what would be kind of cool? What would be a weird, surprising or something like that result that might come out of this? And just kind of pick two variables where you think there might be some interesting thing happening. So you shouldn't just sort of I mean, you can, but you shouldn't just pick things randomly and say, well, maybe this and this. You should try to actually put a little bit of scientific thought into it and have in your mind some sort of hypothesis. So let's say, I see two here, sleep regularity and length of longest romantic relationship. You might think that in order to sustain a relationship, a person needs to be well rested. That if they're tired all the time, they're probably cranky and irritable, and that doesn't make for good relationships. So, you know, that's a bit of a test. So we could say, all right, let's look at sleep regularity. Some people are going to be really regular sleepers, some are not. And let's correlate that with, where was it? This is the hardest part, is finding these things sometime. There we go. Length of longest romantic relationship. And I expect, let me submit and get you to this part. Yeah, because you want to see actually how these variables were coded. So this is what sleep regularity means. Somebody who recorded a 1, they sleep at very irregular schedules. 7 sleep very regular schedules. Now, irregular doesn't really mean a lack of sleep necessarily, but I still think people with irregular sleep schedules would tend to be cranky. Their body wouldn't be properly synchronized. So I think people who are low on this are also going to be low on this, that they're going to not have long relationships. So their longest relationship will be a small number. So small number here will relate to small number there. So you got to think that through. So that means I'm actually predicting a positive correlation, right? So as one variable gets larger or smaller, the other one will do the same thing. That's a positive correlation. So cool. Thought that through, and now I basically test it. I want to be clear on what's going on when you test it. We have a database behind here that probably has upwards of 1,1700 students worth of data. When you do one of these tests, it randomly chooses 200 of those people, which will be important to the replication thing, because the next time somebody does it, it'll choose a different 200 people. And so that'll allow us to see if the results are consistent or not. But for you, you get your 200. You'll get something called a scatter plot that kind of shows you the relation between X, sleep regularity. So as somebody goes to more regular sleep patterns, what is their longest in years relationship? And you can already see from here that there isn't any nice, clear relationship. It isn't that as people are becoming more regular sleepers, they have longer relationships. We just see a bit of a mess here. So I already know visually that there's probably not much of a correlation. But I also just want you to kind of have a sense of everything you're seeing here. This is the raw numbers, in the sense that this is the first person that was selected for you. This is their X variable, how regular their sleep pattern was. So they're on the not very regular side. This is the Y variable, the length of their longest relationship. And you see they're up around 7 years. And then what are these things? Well, they are exactly what they say. So this is just the X times the Y, 21. This is just the X squared, 9. And this is just the Y squared, 49. Now, we only show you 10 people here, but in fact you have more. If you want to see them, you can see them. Here we go. There's the whole set. And then you see at the very bottom of these, what we have is the sum of that whole column. So just all those numbers added together. Sum of the X, sum of the Y, sum of the X times the Y, sum of the X squareds, sum of the Y squareds. Okay, these are the things that show up in statistics formulas. And they can seem scary and intimidating, but let me put this back to the less one. You know, once you kind of get a sense of how they're built, they shouldn't be very scary at all. Because when you actually compute the correlation, these are exactly the things that we're putting in to the formula. The sum of the XYs, the sum of the X's, the sum of the Y's, etc. So I just like to show you all that, or we just like to show you all that, just to sort of demystify the statistics formulas that you will eventually see when you take a statistics course. Okay, here's your prediction. Here's the statistical computation. The critical thing is you end up with a correlation value, and you end up with a critical correlation value. And this correlation value can be between -1 and +1. When it's on the minus side, it suggests a negative correlation. When it's on the positive, it suggests a positive correlation. It can be significant either way. So really, this is a critical value, and I like to say if this one is more extreme than a plus or minus this one, then you have a significant result. This is another way of saying it. If you just take your absolute value of this one, is it well, it is, in this case, less than the critical value. So it's not significant. But that's this is where you make your decision. So this has to be more extreme than a plus or minus that one for you to assume you have some sort of result. And here we don't, right? So this is very close to zero, in fact. We really have no relationship at all. So we hoped there would be, well, we expected at least there would be a positive relation, but there's not. And that's the last question we're going to ask you is, did you get what you thought you were going to get? By the way, this help thing here is a hyperlink of a sort. This will kind of help you think about it. You can click on that at any time and click it off to just get rid of it. So no, for me, this did not confirm my result. I pressed submit there, did that rather quick, but let me just say, when you've submitted your analysis, when you press submit there, what it really does is add your analysis to a list of analyses that you've done. It doesn't actually submit your analysis for your assignment until you click on one of those buttons. In fact, we almost might want to change that first submit to something else. Okay. Add to list or something. But anyway, this is just us talking. But it's this submit that's actually going to submit your analyses. So you can build this list up as you see we've been doing here. And you know, we're not really finding anything significant, although we did find apparently a positive correlation between the number of tattoos a person has and what they think my age is. Interesting. But otherwise, the analyses we've done so far have not shown anything significant. Obviously, the significant ones tend to be more interesting. So, you know, just as a word there, you probably want to do some analyses until you find something that's significant. Now, you can submit something even if it's significant but didn't confirm what you expected. So maybe you expected a positive correlation, but you got a negative one that was significant, and maybe that really surprised you. So you might not have got what you expected, but you can still submit it as interesting, if that makes sense. All right, I did this correlation right here with you guys. Now I'm going to go back and do a t-test just to give you a sense of how that works. So again, anytime you want to go back, you've got the home button here. You can go back there, go back into phase 2, and this time I want to do a t-test. Notice you can go back, by the way, to your list to submit something from your list from here. But I'm going to do a t-test first. Now, just to make sure you're right here, or thinking right, when you're doing the t-test, you have two different kinds of variables now, but they play different roles. So the dependent variable is the variable you're curious about. You think it might differ depending on the level of the independent variable. Okay, so yeah, let me just give you an example. So let's look at our list of variables again so we can think about this a little bit. Okay, this one is, we'll pick this one as our dependent variable. So I remember this variable. This was, at what age do you think somebody is old? Like, what is the age that defines them as being old? So let's say we're kind of curious about that, and we think that a person's estimate of when you become old will depend on, I'm just kind of looking at some of these things. We could pick number of tattoos again, but that's not. Parental strictness. All right, let's do that. Well, now let's do a really weird one. Frequency of showers. This is just an example of a silly one. So you shouldn't really do silly ones. You should really have more of a let's do frequency of meat eating. You should have more of a reason for what you're doing, but you don't have to either. You can play with this a little bit. It's supposed to be fun. So I'm going to play with this, and so I'm going to say something about, I'm trying to think in my head now, that people who eat a lot of meat are going to, I will say, will think people are old at a younger age. I don't know why. This is really just me fishing around. But the first thing you have to do is explain to the to Digital Labcoat how you want to think of this variable, frequency of meat eating. Because originally the question was, how many days a week do you eat meat? The values could range from 0 to 7. You have to turn this into 2 different groups. So I could say, okay, you know what, the people from 0 to 2, I'm going to call these low meat eaters. And the people that are, 5 to 7 then would be a similar range, are the high meat eaters. So notice I'm throwing away some of the data here. Anybody that was the 3 and 4, we're not even going to include in our analyses, and we're going to collapse the 0 and 2s, call them lows, collapse the 5 to 7s, call them highs. We do our analysis, and now the first thing it's going to ask us is, what do we predict? Do we think the low meat eaters? So let's read this very carefully because this is important. I predict that the old age scores, which you have to think in your head, the age at which somebody is perceived to be old, that for the low meat eater group will be higher or lower, greater or less than, or not different from the scores for the high meat eaters. So I'm going to say the low meat eaters, for whatever reason, are going to have a greater number. So I'm just suggesting that if you don't eat a lot of meat, you think you are old at a later age because you're going to be healthy until that later age. Yeah, there you go. I made up something. All right, there we go. So now you click submit. Now the data analysis will look a little different for the t-test and the correlation. First of all, it's going to outline your variables so you're clear about what you did. Now it'll show you nice little bars, one according to the low, one according to the high. And you see I was kind of right, by the way, luckily. At least, whether it's statistically significant is a different story, but at least the low meat eaters, they think when you're about 51-ish, then you're getting old, whereas these people who eat a lot of meat, they think more like 48. Now this is really what statistics is all about. Well, you got a difference, but is that a difference that means anything? Is that just random chance? Well, that's what the statistical process is meant to check out. Again, just showing you when you're doing a t-test, the values that tend to go in the formulas are x's. That's just, again, a first person. This person thought someone's old when they're 30. Yeah. Okay, so these are just, when they thought they were old. So that's the x squared. These are just the 2 different groups. So these are the low meat eaters over here. These are the high meat eaters. So the highs we call y. But again, we're just taking their scores. When do they think somebody's old? We have the y, we have the y squared. And of course, this is for a whole bunch. We could look here, by the way. It's good to be interesting. Good to be interesting. Well, sure, it is. But in this case, we threw out some of the data. So notice that the ends, we don't have that many low meat eaters. Well, we still have 144. That's quite a few. But relatively speaking, we have different ends here. But at any rate, here are the x's, the x squareds, the y squareds. That's what fits in to the formulas, and it's kind of laid out here, a little more complex. What I kind of ask is that you look at these things a little bit, mostly just to demystify this, so that when you see these things in stats class, you've seen them before. And so these things that end up in a formula, you can kind of see the trail of how they were derived ultimately from the sum of the x's, sum of the x squares, sum of the y squareds. Eventually you get to a t-value. It's the same thing I told you in the case of the correlation, that this obtained t-value, in order for it to be significant, it has to be either greater than a positive critical value or less than a negative critical value. It is not, so it's not greater than a positive, it's not less than a negative, so the result is not significant, as it told you. It was getting close, there's a hint of what I expected, but it was not actually there. So no, this did not support my hypothesis. All right, and etc. You can go on, run another analysis as much as you want. Ultimately, you will have a list like this, and what we ask is that you submit at least one of these so that we can try to replicate it in the next step. If this was my list, I would probably pick this first one, this correlation between number of tattoos and people's guess of my real age, because that's really the only one where I found a significant result. So I would probably submit that, and when you do that, you have to give it a title. Now, what we're trying to do here is show you the marketing side of science, really. You can have a really interesting result, but if you don't write a good title on your paper and you don't write a good abstract, which we're not going to ask you to do, but those are the things people look at quickly. They're kind of like a commercial for your product, and if you don't do that in a way that grabs people's interest, then a very important scientific result can be just overlooked by everybody because they're not drawn to it. So this is your chance to try to get people, other students, drawn to your analyses. Try to get them to replicate your thing and think about your thing. So you want a title that does accurately represent what you did, but also kind of grabs interest. So what did we have? We had a positive correlation between the number of tattoos a person has and their perception of how old I was. So, inked people think Jordan's is old. Okay, this isn't very clever. But it gives you a sense of what this is about. I don't know why I put all those. I guess because it was a title, but whatever. That gives you a sense of literally what the analysis is. It is about people who have tattoos. It is about my age. But again, you want to do something that's funny and that kind of grabs people and they want to come and check it out. I don't know if that's a very good one, but that's what I'm going with. And this is just a summary of your analysis and what you have going on. And when you're all happy with that, you submit. All right? And you see a little star there. You can remove your submission, I assume, until the next phase starts. Then you can't. Yeah. So anytime during when this phase is open, you can come back. You can do more analyses. You can play with all this stuff. You can see what you have submitted. You can submit multiple things. And then when you're done, all done, you just log out and everything's fine. So you don't have to ultimately do anything beyond what we just did. Alrighty. That's Digital Labcoat Phase 2, the Analyze phase. I hope you have fun, play with it a little bit, and especially to the extent that the questions are about some specific issue, the more analyses you do, the more you'll have a deeper sense of the variables that are relevant to that issue. So yeah, play around, have fun, do lots of analyses, and find some interesting stuff, because then that interesting stuff hopefully will be replicated, and maybe you'll make the top 10 most interesting results list. Alrighty, cool, thanks.